Hi, my name is Karina Slater, and today I'll be exploring the way a slinky falls when it is dropped from rest. Let me show you a model I made in Python of a falling slinky to explain why this is something interesting to explore. Here the slinky is in equilibrium, then it gets dropped. As you can see, the bottom of the slinky stays motionless until the top of the slinky reaches it, at which point the whole thing falls together. So the question I'll be answering today is, why does it act like this? The main result of this will be that I can explain the motion of the slinky using the net forces on the system. Here I have drawn a slinky at equilibrium as it is being held vertically. It has some equilibrium length that can be determined by setting the force of gravity acting upon the slinky to the force of the spring or tension acting on the slinky. And we can do this because at equilibrium the net force is equal to 0. So the force pulling down on the slinky must equal the force pulling up on the slinky. While the slinky is in equilibrium, it has a few main forces acting on it that will help us determine why the slinky falls the way it does. First is the force of gravity, which acts on the slinky at the center of mass, pointing towards the ground. Next is the tension force, which can also be thought of as the spring force. This force is keeping the slinky suspended in the air instead of dropping to the ground. It is interesting to note, though, that the tension is not equally distributed throughout the slinky. At the top, the slinky has more tension than at the bottom, and this is because there is more weight hanging from the top than the bottom. And this makes sense if we think about the way a slinky hangs in the air, and here's a picture. At the top, the slinky's coils have larger distances between them than at the bottom. In fact, the bottom is almost not stretched at all. So what happens when we drop the slinky? Now the slinky is no longer in equilibrium, so the force of tension that was suspending it in the air is no longer present. So let's think about the forces that are now acting on it. We still have the force of gravity acting at the center towards the ground, but now we also have the spring force acting on the spring, which would pull both ends of the spring towards the center if the slinky was stretched at both ends. This pulling towards the center makes sense if we think about a slinky stretched from both ends lying horizontally on a table. When the ends are released, they spring towards the center, ultimately stopping at the relaxed length of the spring. This same motion happens when the spring is vertical. However, as we saw in the model, one end of the spring does not move towards the center. And why is this? If we think back to the tension force present while the slinky was in equilibrium, I mentioned that the tension force was not equally distributed. There was more stretch in the top of the spring than in the bottom. And I also went further to say there was almost no stretch in the bottom. And this is the key as to why the spring contracts from one end. The top of the spring is very stretched, so it needs to contract a lot to reach its relaxed length. But the bottom isn't stretched at all, so it doesn't need to contract to reach its relaxed length. So why doesn't the force of gravity act on the bottom, moving it downward? Because gravity acts on the center of mass, let's think about where the center of mass is during the duration of the fall. Here I have marked the center of the mass as the slinky falls in this video from YouTube. As you can see, the center of mass is moving downward. And this is because the mass is not equally distributed half and half. The top has less mass because it is more stretched, and the bottom is less stretched, so the center of mass sort of goes towards the bottom more than the middle. And so as the slinky falls, some of that mass keeps falling towards the bottom, so the center of mass keeps moving towards the bottom. So when the slinky reaches its relaxed length, when the top falls to the bottom, the center of mass stops moving down the slinky and remains in the middle. Thus, the entire slinky starts falling downward. So, in conclusion, due to the fact that gravity acts on the center of mass appropriately, meaning the center of mass falls with gravity as it should without the bottom needing to move, the bottom doesn't move. In addition, it has no spring force acting on it to try and pull it up, so it stays motionless.